Welcome to lesson 5 of the prep webinar series today. Currently for me, it's 8:02 a.m. I'm based in Seoul, South Korea, so it's Korean Standard Time Zone. Curious as to where the 4 or 5 of you are today, so feel free to drop in the chat where you're from and what time it is for you. Oh, awesome, Toronto. I'm actually also from Toronto. I'm just visiting Korea for a little bit. And I'm expected to be back in Toronto in June, at the beginning of June. So that's cool. Austin, Tennessee, cool. And we totally should. I hosted the last one, and that was before I came to Korea, like last August, I think we did it, which is kind of insane. It's been like 7 or 8 months since we've done the last Toronto meetup. So when I'm back, maybe, I don't know, like someone should host one right now, because there's a lot of people in Toronto doing launch school. All right, cool. Everyone's mostly from the States. Good to see. Cool. Let's get started today. So I'll start off with just a general introduction. My name is Grace. I'm a TA here at Launch School, but also like a majority of the TAs, I'm also a student at Launch School myself. So I've also been through the entire prep course, and I've also been in the same shoes as you are now, like new to this mastery journey. So I'm hoping this can feel like a safe space for everyone to learn, but also to make plenty of mistakes and to ask questions. Mistakes are definitely where you're burned the most, and therefore it sinks in the most. So on that note, there's no dumb questions. Just the only thing I ask is that you direct all questions to the Q&A feature that the Zoom has rather than chat, since the Q&A feature allows me to keep track of which questions have been answered and which haven't. The chat is more for idle conversation and comments instead, so a question there might be lost. Honestly, we have like 5 people today. Maybe like we can be a little loose about this rule. You're highly encouraged to code along and try out the examples that I'll be showing, as well as playing around on your own to experiment with different results. However, if at any time, if that becomes overwhelming for you or you feel like you're falling behind, I would say try not to worry about it too much and just feel free to watch along. And that's because the material in this session today is not anything that we don't cover in the Launch School's Introduction to JavaScript book. So everything in this lesson today is covered in the Introduction to JavaScript book that's posted publicly on Launch School's website. I based this entire lesson plan on that book, so there's nothing there's no like underground knowledge that only TAs know that we're inserting into this. This is available for everyone publicly on Launch School's website. We're simply using this as an opportunity to make the learning experience into a more interactive one than a usual like solitary one when you're working through Launch School. Yeah. If you end up watching along as well, like there's also a lot of quizzes throughout the entire presentation so that you're still being interactive. You're still being engaged and you're still interacting with the material. So if you have to watch along, like it's totally no big deal at all. For my coding environment today, I'll be using Amazon Web Services Cloud9 IDE, and it's usually what we recommend for those just starting out, since everyone's environments and operating systems can vary. Here we have a reliable, consistent environment that everyone can use. The only thing that you really need to follow along, because you can use any coding environment that works for you, because personally I use Visual Studio Code, VS Code, outside of these lectures. The only thing you really need is to have access to a terminal, which is like this window down here, and you have to make sure it has Node installed. If you're joining us for the first time with Cloud9, then it already comes installed with Node, so you can just open Cloud9 and just use it as it is. You don't have to install anything. Okay. Okay, cool. So Today specifically, we're going to be taking a closer look at arrays and objects. So arrays and objects. Specifically, we're going to take a look at what it means for them to be mutated or mutable. The concept is called mutability, and what that can mean in the context of our code. And then once we have a solid grasp on that, we're going to go over some common built-in JavaScript methods that mutate arrays and objects. Mutating built-in methods. Right? We're going to learn about a concept called variables as pointers, which will help us grasp the difference between reassigning an array or object versus mutating an array or object. So this is especially crucial because once we have the concept of variables as pointers, really that's all you need to know in order to understand the difference between passing data by value and passing data by reference. Okay. If we have time, we're going to be taking a look at some array and object oddities, but we'll see if we can get there. Okay. Let's get started. Okay, so let's just do a quick overview on arrays, right? How we're going to access arrays. I'm going to create a file. I'm going to call it mutable. So we create a file via our terminal with the touch command, and then we write the name of our file and then the file extension. So mutable.js, hit enter. And then on the left, the file is created, and I'm just going to drag that over here. So let's create an array. So I'm going to declare a variable with the keyword let. I'm going to have it be named names, and I'm going to initialize it to an array. And then within the array, I'm going to have 4 names. Here's Pete. Right? So remember that we can access each individual element of an array by appending the same square brackets that we used to create the array to the end of the array. Here the array is referenced by name, so I can just use names. And then we provide the index of the element we want in between the brackets. So the important thing to note about arrays is that the indices start from 0. Arrays are 0 indexed. So if you want the first element, it's going to be index number 0. If you want the second element, the index is going to be 1, 2, 3, and so on and so forth. So if I want to access the name Pete, I'm going to have to go for the index number 1, which references the second item. Okay. So if I want to output that name to the terminal, I'm going to wrap that expression in a console.log call. I'm going to save the changes to the file, and then I'm going to run the file. Node mutable.js, hit enter, and we get the name that we desire, which is Pete. Excuse me. So then by extension on mutability, what you have to know is that arrays and objects, because they are not primitive values, they are mutable. We can mutate them. Let me demonstrate. So I'm going to try modifying this array that we created. Instead of logging the name, one thing we can do is actually we can assign values to certain indexes. So I can actually change the value at index 1 to another name, or any other index that I desire, for example. So if I reference the item at index number 1 again, so remember initially that the value that's contained at index number 1 is the string Pete. What I can actually do is reassign which value is going to be at index number 1. So let's change it to another name, Claire, and then save the changes. Actually, and then I'm also going to log the entire names array just so we can see what changes have occurred. So I save the changes to that file again, and then I'm going to run that file again. I'm going to hit enter, and we can see that we mutated the array, right? So again, we created an array, we reassigned index number 1 to be not Pete anymore, but to the new string Claire, and then we log the value to see that in our console, the array is different, right? The array has been mutated. The really important thing here to know is that we are not mutating the string. The strings are immutable. We cannot access, we're not changing the string. We're actually changing what's in the array. Okay, so I think students often get confused as to what's happening is that, oh, we manipulated the string Pete. That's not true. What we did was we manipulated the array so that index number 1 holds a completely different value than what it originally was. Okay. Okay, cool. So we've mutated the array by reassigning an index, but I can actually add a new element to the index to the array as well in a similar manner. So I would just have to take an index that's not defined. So 0, 0, 1, 2, 3. So the last index in my array is index number 3. So if I assign index number 4, which doesn't exist yet, to a new element, let's say the name Trevor, I'm going to save the changes. Again, run the file, and we can see that I've created a new element in the array, right? So reassigning individual indexes within an array is a mutating action. That's important to remember. Similarly, objects work in very much the exact same way. If let's create an example, actually. Let's let pets equals to curly braces, so that's going to be an object. I'm going to have a variety of animals and their respective sounds that they make. Pig, points. Right? And then again, if we want to access the element, the value of a particular key in the object, we take the pets object, and then again, similar to how we access the index, the elements of an array using the index, we're going to create a square bracket, and then we're going to use the key of the value that we want. So I want the value meows. So that means within the square brackets, I'm going to have to put cat. However, one thing to remember about objects is that the keys are always strings. No matter what value you see there, even if there's no quotation marks around it, it can be even a number. What you have to know is that JavaScript will coerce all keys into strings. So this is actually going to be something like this. Even if I didn't put the quotation marks there, if I left it as this, JavaScript is going to coerce it into a string. So that means for this syntax, the square bracket syntax, I'm going to have to put the string, the quotation marks around it. Okay, so if I save the changes there, we can see that again, we get the value meows. So that means I can actually reassign, I can mutate the object as well. So I can do something like, I want pets, the key of cat, to reference a different value, which is going to be hers. Right? And then similar as before, I can create a new key that doesn't exist on the object. I don't know, some otters make. That wasn't a good decision. Splash, sure. Oops, so I have to log the new. I have to log the entire pets array to see, or the pets object, in order to see the changes that I've made. Right, so we can see we have mutated the object. Arrays and objects are mutable. So dog barks. Initially, cat was purrs. Initially, it was meows, but now we changed it to purrs, and we also added a new key value pair, which is otters and splash. Okay. Something you don't need to know in depth, but something you should know is that the reason why arrays and objects behave in this similar manner is because technically arrays are objects. Okay, they behave similar in terms of this mutability concept in which they're both mutable. Okay, so you will learn a lot more about what an array means to be an object in later courses, but for now you just need to know that arrays are objects and therefore they are mutable. Okay. Okay, awesome. Any questions? Okay, there are a couple questions so far. let's see. Okay. A couple questions. So, does added mean mutated? So if a new element is added to an object or an array, it definitely means that it's mutated. But there are also other ways that an array or object can be mutated. It doesn't necessarily have to just be an addition of a new element or a new key value pair. It can also be we might change an existing one, we might remove one. I think that's pretty much all it means for it to be mutated. It just has to be altered in some way. Okay, good question. Are there certain data types that cannot be added to an array? So arrays are what we call heterogeneous. So arrays are heterogeneous, which means that we can add any values to arrays that we want. So I can create an array with all 5 of our primitive value types. So it can be a string, it can be a number, it can be a Boolean value, so that's true or false. It can be undefined or null, and we can actually even have objects and arrays within an array as well. So we can literally have any value type within our arrays. So right, so that's our object, and I can have another array there as well. So you can see that I've created quite a long array. Actually, let's wrap lines so that it falls to the next line. So I'm going to initialize this variable to hold this new long array that we've created that has a bunch of different values in it. And we can see that if I run the file, it's not an illegal action. We don't get an error of any sort. Something works similarly for objects as well. So in this object that I've created, we have key value pairs, and as I've stated, the keys are always strings, but the values can also be whatever we want it to be. The values can also be similar to array. It can be all the primitive value types, and it can also be an object or an array. So I can even nest another object here as well. Right? And these are all valid actions. Good question. Another question is there a limit to the number of items that can be added to an array? To my knowledge, I don't think so. Maybe, I think it really depends on the memory in JavaScript. So I think that's something like 30,000 lines, but I'm not entirely sure. Yeah, I've never also to all the programs that I've ever created, I've never run into an issue of like the limit of elements in an array. So I'm going to say you don't have to be too concerned about how many items you can add to an array. Okay. Those are great questions. Awesome. I hope those are helpful. If there aren't any other further questions, or if I've appropriately answered those questions, let's move on. So far what we've done is we've kind of manually gone in with reassignment, and we've altered these arrays. We've mutated the arrays, right? We kind of had to find the key or the index that we want to alter, and then we reassigned it. This kind of a very manual method of mutating arrays and objects. But actually within JavaScript, we have something that are called built-in methods, which are simply functions, really. So if you've ever played with functions, then you know that first we have to define a function in order to execute the function, right? We define the procedure before we can use the procedure. However, there are certain procedures or functions or methods that are already built into JavaScript so that we don't have to define them, right? A good example of that is console.log, right? So I didn't have to define this method anywhere or this function anywhere, but I can invoke it and I can use it to output certain things to the console, right? So we also have similar methods that we can mutate arrays and objects that are already built into JavaScript. So we don't have to define them. We can simply call them. Okay, let's go through a couple right now. And I'm going to create a new file for this. Again, I'm going to use the touch command in my terminal, and then I'm going to write names.js. It's going to be a new file. I can see it's created on my file explorer on the left. I'm just going to drag that in over here. Okay, similar to before, I'm going to declare a names variable and initialize it to an array again. And then it's going to be same names as before. It's going to be Grace, Pete, Swoop, and Karis. Right? So the way that we call array methods is that we take the array that we want to use it on. So I can also I don't have to declare the variable, and I don't necessarily have to save it to a variable. I can also just get the array and I can call it directly on the array, which means we're calling the push method. So what I do is I append a dot, a period, and then the words push, and then the parentheses. So I can either append it to the end of an array, or I can append it to the end of a variable that holds an array. So names.push and the parentheses. Okay, so this is the basic syntax to calling a method or calling a function, really. We usually use, if we're just calling a function that we've defined, you'll often see that we just simply use the syntax, which is the function name and then the round parentheses. When we're calling a method from an array, it's often dot push, dot filter, dot map. Okay, that's how we call an array method. Okay, so the push method takes the argument that we pass into it, whatever we pass into these circular parentheses, and it adds the element to the end of the array. So this is a mutating operation. So let's create a list of mutating operations, mutating methods. So one is the dot push method. Right. So we did a similar thing before, except we kind of like manually found the index, and then we reassigned the index to be a certain element. So here instead, I can just use the push method and it will do that for me. Let's see the result of the mutation. So I'm going to run the file, and we can see that we have the same values, the same 4 values, but at the end of the array, we've appended a new value, which is clear. So push specifically adds the value to the end of the array. Okay. So we also, if we have a method that can add elements to the array, we can also remove elements from the array. So that is known as the dot pop method. Okay. So I added actually let's pick that out. So we're starting back from the beginning with just the 4 names here. We don't have the declare element there anymore. So instead, I want to remove the last element of the array. So I'm going to call names.pop. Right? And we don't have to pass in an argument to pop, because what pop does is it simply removes the last element, no matter what it is, from the end of the array. Right? So that means it doesn't need to know what element we're referencing. And in fact, we can't really reference a specific element with pop. It will simply take the last element in the array and remove it. So if I save the changes, we should see when we run the file that the last element has been removed. We don't have the Karis string in our array anymore. Okay. Cool. Let's go through one more. This is another interesting method. I usually don't go through this one, but I think it could be helpful. So another cool method that we have is called splice. So names.splice, right? This is different from slice. This is not the same. Splice is not equal to slice. Okay, splice with a P is a mutating action. Slice is not a mutating action. So I won't be going through slice today, but I will be going through splice. So splice is another method that removes elements from an array, but unlike pop, we can actually specify which elements we want to remove with the 2 arguments that splice takes. So splice takes 2 arguments. The first is the starting index in which we would like to remove the element. So let's say I want to remove the string Pete from our array. So that means we have to start with the index that Pete is at. So if we recall, Grace is index 0, so that means Pete is index 1. So I want to remove the element at index number 1. And then the second number refers to the number of elements that I want to remove starting from that index. So let's say I just want to remove Pete. That means I only want to remove one element from starting at index number 1. So I'm just going to put 1. Okay. So then if I log the values of names again, we can see that Pete has disappeared, right? This is a mutating method. It took starting from index number 1 and it removed one element. Okay. What I can also do is I can specify that I want to remove 2 elements starting from index 1. So that means starting from index 1, that's Pete, and 2 elements means also the string Luke. So if I save changes, we can see that in our new array, in our mutated array, sorry, it's not a new array, it's the same array, but we've mutated it. We can see that Luke and Pete have both been removed from our array. Okay, so that's another mutating method. Okay, so far I've touched on those 3 methods that mutate the arrays that it's called on. But what does it look like when we use a method that doesn't mutate the array, right? That doesn't mutate the caller, as we would say. Let's see that with the concat method. Okay, so again, I'm going to keep the same 4 names array here. This time I'm going to call .concat. And what the concat method does is it basically kind of it returns a new array that has the elements of the array that we called it from and also the array that we passed into concat. So it's basically merging the elements of both arrays into one array and then returning that as a new array. Okay, so that means we're going to pass in an array. And on this array, I'm going to have 2 names, which is Claire and Trevor. Okay, so something interesting is going to happen here. Let's see what happens when I log the value of names. When I log the value of names, we're going to see that it hasn't changed. The array referenced by names, it hasn't been mutated. So then what's going on here in line 3? We called a method, but how do we kind of look at the result and how do we see what's happened? So again, what concat has done is that it's created a new array. So that means in order to see the result of that new array, if concat returns that array, I'm going to have to initialize a new variable and hold that new array. So it's going to be let more names equal to names.concat. And so now I've stored the value, the new returned array into a new variable. So that means I can also log the value of more names. So I'm going to do that after here. Save the changes to that file and then let's run it. So we have the first array, which is 4 elements, the first 4 names, and then concat returns a new array with both elements combined together. And then it gives us a new array. So something that's important to know is that names and more names. So let's wrap this in a console.log statement. So we're using the strict equality operator here, the 3 equal signs, to check whether or not names and more names are the same array, right? So if I log that value, we can see that it's false. So the way that arrays and objects work is that they're created somewhere in memory, similar to how a variable is, and we can reference them. And sometimes even if they have the same values, it doesn't mean that they're necessarily the same array. Because they're mutable, it means that we have to take extra care to know that which array methods return new which array methods return new arrays, or whether they mutate the array in place. Okay. Yeah. So that's the concat method. Okay. I just want to show one more example. So to really drive this home of what it means for there to be different arrays. So let's declare variable names 1, and I'm just gonna have 2 names in here. just Grace and Pete. Now I'm going to declare a new variable, names2, and I'm going to have the exact same values, right? However, we're going to first check whether or not the arrays are the same, right? For those of you who are new to arrays and objects in JavaScript or in general programming, you might expect for this to log true. However, it logs false because the strict equality operator, when we use it with arrays or objects, it's not checking for whether or not it has the same value, but in fact, it's checking whether or not it is the same array or same object in memory. And because we've declared and initialized two different arrays, these are not the same arrays and memories. So that means I can actually mutate the first array. And then if I see the result of both arrays, we can see that one was modified and one was not. Right? However, if I have it so that both variables reference the same array, so names2 is going to be equal to the same array and names1, and I mutate the first array, we're going to see that, in fact, they are both pointing to the same array, so any changes made onto one array is going to be visible in that second array as well. Okay. Okay. So, any questions so far on that? I will be expanding a little bit more on pointers. So I have a question. So if you were to use concat with a string as the argument to add an element to the array, is it merging the string as an array to the called array? So I believe the question is, let's create a new file for this. Test.js. So if I have an array, and I use concat, and remember that concat returns a new array. So let's check the result by saving that result to a new variable. If I call .concat with just a string, I actually don't know what will happen. Let's see. So let's pass in a string goodbye, and then log the value of newer. Node test.js. Cool. So it looks like what concat does is that it will take the string and it will simply concatenate it into the array as an array. What's the method? Concat NVN. So what I'm doing right now is I'm checking what's called the developer documentation of JavaScript. So the MDN documentation for JavaScript. And I'm going to check what the concat method does. So to my knowledge, I thought it's to merge two or more arrays as the documentation states, but it looks like if we pass in a string as well, it will still accept that string and place it into the new array and concatenate it to the new array. So this is an excellent tool to use when you're, especially for starting out with your methods and kind of getting familiar with them, is to check the documentation, because that's what you have to do in order to understand how these methods work. All right, but I would say that I think the intention of concat is to use two arrays and to merge two arrays. So I would try and be mindful and show my intention that I intend to merge two arrays whenever you're calling the concat method. And this is because if other people are reading your code, they might think that you made a mistake. They're like, oh, like maybe you weren't trying to call concat. Maybe they're trying to call something else, but they ended up making a mistake. So you want to be clear with your intent, especially because the result is the same. Whether we use the string or whether we enclose that string in an array, we still get the same result as we see when I run the file now. So you want to be clear in your intent. Okay, I hope that answers your question. So I have another question here. Actually, I'm gonna answer the follow-up question just because we're in that context right now. So the question is, are strings a list of characters and thus arrays in a sense? So the interesting thing about strings, especially in JavaScript, I believe this is not the case in a lot of other languages, is that strings have indices as well. They have indexes. So if I initialize greeting to be the string hello and I access the index 0 of greeting, then what happens is I can do, oops, I have to log it. We're going to see that I can actually access the first letter, right? The first index of the string. So similar to arrays, they have indices. However, it's really important to note that strings are not arrays. Strings are primitive values. So our primitive values, which are building blocks, are like kind of like the atoms of the programming world. They can't be broken down any further and they can't be mutated. So the 5 primitive values are strings, numbers, booleans, which is true, false, undefined, and null. Okay, so this is char characters. These are numbers, 0.5 and -5. And then we have undefined and null, right? They are immutable. So if I go back to that string example, I can access each individual character by using the index. But if I try to do something like this, creating 0 is equal to the capital letter B, let's see what happens. What happened to greeting? We're going to see that it didn't change. It still remains the string hello because we're not able to mutate strings. What I can do is I can reassign what the variable is holding into a new container, into a new string. Right? And we can see that we have the new string. But what happened is that we took out the string hello from the greeting container and we put in an entirely different new string called bello. Okay. So we're not mutating the string, where it's a new string entirely that we're putting into the greeting container. Okay. So strings have indices similar to arrays, but they are not indices. Great question. So back to our other example with our two names. Well, in this case, we only have one array, and now both of our two variables, they reference the same array. So the question is, then here, would names 1 and names 2 be equal? And the answer to your question is yes. Oops, node names. And the answer to your question is it's true, yes, because now they reference the same array. However, again, if we had it differently as we did before, where it's actually two separate arrays, because I've initialized two different arrays here. Let's get rid of these. Now when we log in, it's going to be false because they're two different arrays. Great question. Last question I have here is, what instance would .concat be used on an array? That's a good question. I would say, like, throughout programming, I haven't really run into it, but actually I've used it recently, and it was to create a new array, basically. If you want to often what happens in programming and in creating programs is that you have a function and that you want to pass in an array, and you want to maybe output a new array, right? But usually what you don't want to do is you don't want to manipulate or you don't want to mutate the input array. You usually want to return a new array because you want the data to keep its integrity. So usually we'll use a variety of methods in order to create a new array that has the desired values that we want. And we use methods like concat or slice in order to prevent mutations to the original data array. Okay. There's plenty of other ways to use to create the same results as concat. So I would say that, like, you know, it's not like you have to know the ins and out of this tool, concat. I would say just like keep it in your tool belt, and if you see a use for it come up, then that's kind of appropriate to use it. I can't really think of like specific cases off the top of my head. If you want to create a new array where you want the original array and some more elements merged into it, then that's a good case, but I can't really think of anything super specific right now. Okay, really good questions. Keep them coming. Okay, I'm going to be moving on. So we're going to extend a little bit on this idea of mutating an array or object versus reassigning an array or object. So far we've taken a look at mutability, what mutability means, and we've looked at different ways, either through reassignment or through built-in methods, to mutate our arrays and objects. And so the reason why it's so important to lay that foundation down of what mutability is because there's a difference between muting an array or object and reassigning an array or an object. This is super important to understand. So you might have seen a lot of things that I did just now that might have been a little confusing, but we're gonna really break that down. And we're gonna use this concept of variables as pointers to help us picture this better. Okay, so let's create a new file. So I'm gonna create a new file, gonna be touch. It's gonna be pointers.js. I'm gonna enter. That's my new file. Right. So in this new file, I'm going to declare a variable with the let keyword, and I'm going to initialize it to the value, the number 5. So the number 5 is a primitive value. Next, I'm going to declare another variable named bar with the let keyword, and I'm going to initialize it to be the same value as foo. Okay. Next, I'm going to reassign the value of foo to be the result of the expression foo plus 3. Okay. So then, what are the values of foo and bar now? Right? What is the value of foo now, and what is the value of bar now? Right, so foo is 5, bar is equal to foo, and then now foo is equal to foo plus 3. So if I log that, let's note it, we get 2 different values. We get 8 and 5. Okay, so I declared foo and I stored the value 5 into foo. I declared the bar variable and I stored the value that's currently stored in foo into the bar variable. So that's currently 5, right? Then I reassigned foo to be the result of foo plus 3, which is 5 plus 3, which is going to be 8, right? So I reassigned foo to be foo plus 3, which is 5 plus 3, which is 8. So foo is now assigned to the number 8. So that's why in our last result, we get foo and bar is respectively equal to 5 and 8, right? So when we manipulated what value was stored in the foo variable, that didn't change anything about what's stored in the bar variable. Let's break that down. This is an example of how primitive values work. So yeah, let's break that down. So line by line. Here we have the first line. So we declared the foo variable. So what's happening on the right is we're visualizing what's happening in JavaScript. So whenever we declare a variable, so that's just simply let foo, what we're doing in JavaScript is we're creating a container. We can think of it as a container where we're creating a space in memory. We're allocating a space in memory, which we can just think of as a container, and we're labeling it with an identifier. So we're just basically taking a container and we're labeling it foo. Okay. When we initialize a value, so when we give it the value 5, what we're doing is we're storing the number 5 into the container. Okay. So then when we have the next line, let bar, as I've mentioned, what we're doing is we're creating a container and we're labeling it bar. Then when we initialize it to be the value of foo, the current value of foo is the number 5. So with primitive values, again, we store the value into the container. So as we can see here, we have 2 different number 5s, one that's stored in the foo container and one that's stored in the bar container. They're independent of each other. They are not they're not referencing the same number because again, with primitive values, they're not mutable. So instead we have to store a copy of a primitive value into each variable, right? Next line, foo is equal to foo plus 3. So what we're doing here is we're reassigning what value will be stored inside the foo container. So what value that we want to store in there is foo plus 3. So JavaScript will look up in memory what's currently in the foo container, which is the number 5. So that means 5 plus 3 is whatever 5 plus 3 evaluates to is the new value that we want to store in the foo container. So we're going to take the number 5 out and we're going to put the number 8 in. And as we can see, that did nothing to the bar variable, right? The number 5 is still stored. That other number 5 is still stored in the bar container. And anything we did to the foo container didn't affect what happened in the bar container. And that's why our final result is foo is logs, console.log foo logs 8 and console.log bar logs 5. Okay. So the takeaway is that primitive values are stored within the container. If we assign another variable to store the same value as another variable, what we do is we take a copy of that number and we put it into the container because I can't share this number between the two containers. If I want to put another number into another container that has the same value here, it has to be a copy. Okay. Now let's see this contrasted with arrays, which again, arrays and objects are quite similar, so you can exhibit the same behavior with objects as well. But let's just use arrays for now. So I'm going to declare foo again, and this time I'm going to initialize it to an array with 4 numbers, 1, 2, 3, 4. I'm going to declare bar again, and similar to the last code, I'm going to have it be the same value as foo. I'm going to call a mutating method. Remember, push mutates the array that we're calling it from. And what I'm going to do is I'm going to push the number 5 to our array, which means a what? We are adding the number 5 to the end of our foo array, right? Now I'm going to log the value of foo, and I'm going to log the value of bar. What's happening here? Let's see. So if I hit enter, interestingly enough, we've somehow mutated the array that is both referenced by foo and bar. Okay, so what's really happening here? So what's happening is that we have only one array in this entire code block. So we have foo, the array referenced by foo, and then we have bar referenced the same array as foo. And then so that means when we call a mutating method onto foo, since bar is referencing the same array, when we log the values of foo and bar, we can see the change reflected in both calls to console.log. Okay, let's break this down. What's happening in memory when we declare variables and initialize to an array? It's a little different from primitive values because primitive values, we stored the value itself into the container. So like before, let's declare our foo container, our foo variable, and label it foo. And this time we're going to initialize it to an array. So the way this works with arrays and objects is that the array or object will actually be created somewhere else in memory. So here we have in memory, we have the foo container. And then somewhere else in memory, we now have this array that's been created. Okay. What happens when we initialize a variable to an array or an object is that it actually holds inside the container a pointer to the array that was created in memory. Okay, so what we say is that we store a pointer into the variable. I'm not storing the array into the container myself, container itself. I'm storing a pointer or a reference to the array into the variable. Okay, so the next line, we have let bar is equal to foo, which means, again, we're declaring a variable. We're creating a variable in somewhere in memory in JavaScript, and we're going to label it bar. And since what we've done here is, I have 2 of the same slides. Here, since we've initialize it to be foo, what that means it's going to be the same value as foo. That means we're going to store the pointer to the same array as foo. Okay, it's important to note we're not pointing at foo. Can I move this arrow? This is not what's happening. We're in fact pointing to the same array as foo. Okay, we're pointing to the same value that foo is pointing at. Because, well, we can think of it this way. If it's holding a pointer to the array, then what we're storing inside the bar is the same pointer, right? The same pointer that points to the array. So as we can see by our diagram of what's happening in JavaScript memory, foo and bar now point to the same array. So that means if I call the push method onto foo, which again is a mutating method, that means I'm going to mutate the array that foo points to so that there's a new element added to it, the number 5. So as you can see in our diagram, bar is still pointing to the same array. So that means when we call foo and when we call console.log with foo and bar arguments, we're going to see the same array with the mutation in both console.logs. Okay, so in this code, there's in fact one array. Okay. Okay, let's do one last example to show what happens in. Yeah, let's show what happens. This is an important gotcha. I kind of demonstrated before, but let's really drill it home. Okay, so now I'm going to show this example with objects just so we get some exposure to different kinds of data types. So I'm going to create 2 objects and they both have the same key value pairs. They have the key value pair A is equal to 1. Sorry, I wouldn't say is equal to. A is assigned to 1 and B is assigned to 2. Okay. Similar to both code snippets that I've just demonstrated, I'm going to mutate one of them. So I'm going to mutate the object referenced by foo, and I'm going to do that by reassigning one of the keys to be another value. So to the number 99. So then we just went on this whole spiel about how we can mutate an object or an array, and the mutation will be shown in any variables that reference that same object or array. But what's happening here? So let's run the file and see what happens. Will foo and bar log the same value or a different value? And in fact, we're going to see that they are different objects and they are logging different values. Okay, so we can see that when we mutated the foo object by reassigning the B key to be the number 99 instead of number 2, that change is reflected in console.log foo, but that change is not reflected in console.log bar. Okay, so why is that? Let's break it down again. Somewhere in memory, I've declared the variable foo. So we create a container in memory with the label foo on it. And we initialize it to be an object. So remember with objects again that we're not storing the object within the variable itself, but instead the object is created somewhere else in memory, and then we store the pointer to the object within the variable. Right? Next line, so let bar, right? We declare the bar variable somewhere in memory, the container is created, and we initialize it to be another object that has the same key value pairs as the other one. But again, it's not the same object that's referenced by foo. In fact, it's another object, right? As shown here, we're not saying let bar is equal to foo, we're saying let bar is equal to this new other object that we've created. So again, another object is created in memory, even though it has the same key value pairs. And in bar, since we've initialized this object to be the value of bar, we're storing a pointer to that object. Okay, so that means foo.b is equal to 99. We want to reassign the key b to be the number 99. So that's only going to happen in the foo object, right? The object referenced by foo. So that means, again, if we log the final values of foo and bar, we get this object, A1, B99, and we get the value of bar, A1 and B2. Okay. And then as someone had asked before, if we run console.log is foo equal to bar, we get false. These are 2 different arrays, objects, right? Can I go back enough for the other example? Right, so if I go back to the other example in which I have the foo array points to an array, and then I have bar point to the same array, log is foo equal to bar? The answer is true, because they point to the same array. Okay, cool. Any questions so far? I've got a quiz, and let's dive into the quiz. So a bit of disclaimer for the quizzes. They start off relatively simple, but then I definitely do try to complicate things a bit. And these quizzes are definitely meant to test your in-depth knowledge about what's being taught here. But if this is your first time being exposed to it, you might not catch all the nuances. So in a sense, these quizzes are designed to trick you and to really test like a mastery level. So if you don't necessarily get all of them, like, don't be discouraged. They're definitely designed to trick you. So let's get started with those. Cool. So what are the values of foo and bar? I've been told that the quiz window pops up right in the middle of the screen, but if you need to see the quiz questions, then you can drag the quiz window yourself to the right. What are the values of foo and bar? Remember to ask yourself, okay, are we working with primitive values, or are we working with objects and arrays? And therefore, how are they stored in variables? How does that work here? Oh, you're right. Yeah. So somebody mentioned in the chat the answers aren't formatted correctly. The variable names show up for some of them, but not all of them. So yeah, there's that the last answer in the poll. It should be foo and bar there as well. And then the third one should also say foo and bar. Sorry, I'm gonna address that. Thanks for catching that. So the third and fourth answers should look something like that instead. Okay, so let's take this up. Let's take this back. I'm going to create a new file for this. Crystal.js. Right. So here's the example that we have. And for those of you curious, what happens is that Google Slides, when I use quotations in Google Slides, it creates a different quotation mark that is allowed within JavaScript files. So that's why I always have to change it, unfortunately. So if you're copying pasting from somewhere, you might have that issue. Just make sure the string quotation marks are legal ones. Okay, so let's break this down. Let foo is equal to the lowercase string hello, right? So we're working with primitive values, and this means that we store the string hello into the food container. On line 3, we declare a new variable bar, and we have it equal, we initialize it, not equal, we have it initialize it to be the value that's currently stored in hello, in foo. we initialize bar to the value that is currently stored within foo. Okay, so then that means, again, primitive values are stored directly within the containers themselves. So what we take is the current value foo, which is hello, and we store it into bar, which means we're dealing with two different containers, but they both have two different strings hello in them, because again, primitive values, we store a copy. Then we reassign foo to be the result of foo dot to uppercase. So this is a string method that returns the uppercase version of the string that we call it on. So this is the same thing as saying hello to uppercase, because right now the current value of foo is the string hello, right? And remember that we're reassigning. So we're taking out what's in the current foo container, which is the lowercase string hello, and then we're putting in the uppercase string, right? So now we have two containers. Bar has a lowercase string hello, and foo has the uppercase string hello. So that means the final values of foo and bar, whoops, console.log foo, console.log bar. I see the changes. The final values of foo and bar are uppercase hello and lowercase hello. So the third answer is the correct answer. Okay. Remember, strings are immutable. We cannot mutate them. Even if we call a method onto them, we can't mutate them. I'll demonstrate that really quickly here. So foo is equal to hello, foo dot to uppercase, right? I'm calling a method that returns the uppercase version of the string, but it doesn't mutate the string because we can't mutate strings. So we can see if I run this program, even though I call this uppercase method, we can see that foo remains unchanged. However, if I reassign foo to be the result of this, that means I'm reassigning foo. I'm not mutating any string. I'm not mutating hello. What I'm doing is I'm taking the hello out of the container foo, and then I'm putting in the new hello, which is an uppercase version. So then if I run the file now, we can see that it's uppercase hello. Okay. Strings are immutable. Everything that's not, all primitive values are immutable. And then anything that's not a primitive value is an object or an array. Okay. Thank you for catching the formatting. I'll write a note to change that today. Hopefully this one's formatted correctly. What are the values of foo and bar? So the first value in each answer refers to foo, and the second answer refers to bar. Again, ask yourself, are we working with objects or arrays, or are we working with primitive values here? And depending on what it is, then how is it going to influence how they're stored into the variable? I'm gonna give it about 20 more seconds. Just take your time, break the code down line by line. Especially in the beginning, you shouldn't know this answer like right from looking at it. It's okay to like break it down line by line, and the more you do that, down the road, you'll just look at it and you'll know instantly the answer. But in the beginning, you have to take it slow. Okay, let's take this answer up. I think for the most part, people did great on this one. Okay, so what's going on here? We have, we declared a foo variable and we initialized to an array. That means we declare the foo container. And remember, when we initialize a variable to an array, the array is created somewhere else in memory, and what we're storing in the container is the reference to the array, right? The pointer to the array. We don't store the array into the variable. So then on line 3, we declare another variable bar and we initialize it to a different array. These look like they're the same array, and they're similar in the fact that they both have no elements in it, but the fact is that they're two different arrays. So we have two different variables holding a reference to two different arrays. On line number 5, we call the push method on the array referenced by foo, and we add 3 elements to it, 1, 2, and 3. Remember, push is a mutating method that adds the elements that we currently that we pass into it into the array, right? So we're adding the elements 1, 2, and 3 into this array. Okay, this is where it gets tricky. So bar is equal to foo index 0. So what's happening here? So if currently our foo array looks like this, because we called the push method onto the foo array, our foo array looks like this. We have 3 elements to it, 1, 2, and 3. So what's happening on line 8? Break it down. So on line 8, we take the variable bar and we reassign it. What does reassigning mean again? Reassigning means we take out whatever's in the container and we're putting something new in it. Are we putting a reference, or are we putting in a primitive value? Let's check. So what does index 0 of foo evaluate to? So again, if we look at the foo array after it's been mutated, whatever's at index 0 is the number 1. So this expression essentially means reassign bar to be the primitive value number 1, or reassign bar so that the value that's stored in bar is the primitive value 1, right? So that means we are taking out the reference. So on line 3, bar currently holds a reference to an array, right? But on line 8, we're taking out that reference and we're now putting in a primitive value. So bar now references or now holds the number 1. So if I log the value of foo and I log the value of bar and I save the changes and run the file, we're going to see the array 1, 2, and 3, but the number 1, not the array with 1 in it. This is incorrect. It's not the array with the number 1 in it. It's simply the number 1. Okay, so the correct answer is the third one. Okay. Tricky. All right. I'm aware that we went over time, but I've got 2 more quiz questions, and then yeah, then we'll see from there. Okay, what are the values of foo and bar? What are the values of foo and bar here? I'm gonna give it about 10 more seconds and then we'll take it up. Okay, let's take it up. So, cursive Google Slides. Okay, cool. So let's break it down. Line 1, we declare a foo container and we have it initialized to an array, which means the array will be created somewhere in memory and we're storing a pointer to the array within the foo variable. On line 3, we declare bar and we initialize it to be foo. So that means since foo currently points to an array or holds a reference to an array, that means bar is also going to hold a reference to the same array. On line 5, which is where the tricky part is we're reassigning index 0 of foo to be bonjour, right? To be a new string. So what's happening here? We're mutating the array because what we're doing is we're changing whatever's at index 0 to be another value. Okay, so that means we've reassigned it to be a different, we've reassigned the element at index 0 to be another string. So that means we mutated the foo array to be the array bonjour and hi, right? But if we remember right, bar is also holding a reference to the same array. So in fact, there's only one array in this entire code snippet, and bar and foo variables are both pointing to the same array, which means any change is reflected because we manipulated it via the foo array by reassigning index 0. That change is also going to be reflected in the bar array because in fact they are the same array. So the answer is bonjour and hi within the array. So the correct answer is the third one. Okay, last question. What are the values of foo and bar? What are the values of foo and bar? I'm gonna give it maybe like 15 more seconds and then we'll take it up. Or maybe I don't have to because I think, okay, I'll give it 5 more seconds. 3, 2, 1. Okay, I'm not gonna break it down because I think everyone basically got it. So we declare a foo variable, initialize it to an array. We declare a bar variable, initialize it to a different array, and then we push whatever element is at index number 1 of the foo array, which is the number 10, into the bar array. So we're mutating the bar array by adding the number 10 to it, essentially. And so the correct answer is the third one. One array with 5, 10, 15, and another array with just a number 10. Okay. Great work, everybody. I guess like everyone's trying to get the hang of it. Okay, so as I mentioned before, I'm pretty aware we're well over time, about 15 minutes. That's usually how these go, to be honest. So if you do have to run, I do appreciate you sticking around, and all I ask is that you fill out this Google form. It really helps us to know what's working with these workshops and what isn't. If this was any help for you at all, like definitely mention it in the course feedback or in your assessments. But yeah, thanks so much for attending. If you do end up sticking around, I think I'll be continuing to just quickly talk about pass by reference and pass by value, because once you get what we've covered so far, once you have that understood, the pass by reference and pass by value is really easy to understand. So I'm going to go over that really quickly if you have the time to stick around. However, if you do have to run, again, I respect your time and that's totally fine with me. So thanks so much for attending if you do run right now. And if you're looking to figure more about or to learn more about PDAC, which is the problem solving framework that Launch School has come up with in order to approach coding problems, then definitely tune in next week where I'll be demonstrating how to approach a small problem using the PDAC framework live, and I'll also be taking different approaches on a basic problem. I'll be showing you how to debug your code and how to read the stack trace and how to use documentation and also the node REPL in order to solve small problems. So yeah. Thank you so much. I will give it maybe another, I'll say let's take like a bio break of like 1.5 to 2 minutes since we've been sitting for a long time. And then I'm gonna go through with pass by reference. And then once I quickly breeze through that, I'll be opening the floor for any questions, and I'll be sticking around for maybe like 10 to 15 minutes for any additional questions, whether it's about material that I've covered here or any other material in the Launch School's JavaScript courses. I'm happy to answer. Okay, so yeah, I'll give it a minute and a half to 2 minutes, and I'll be right back. Okay, shall we get started? Okay, I'm going to breeze through pass by reference just because yeah, let's keep it quick. So back to pass by value versus pass by reference. So if you've understood everything that we've covered so far, and that's if you have that base covered, really pass by value and pass by reference isn't as complicated as it appears to be. So if you understand what we've done, which is variables as pointers, variables storing pointers or storing the value when it's a primitive value itself. If you understand that concept and object mutability or array mutability, then this will be very easy for you. So pass by value and pass by reference are concepts that we use to refer to what happens when we're passing arguments into functions. Okay, when we declare a function, we use parameters to indicate that we expect data to be provided when we invoke the function. So for functions, we have parameters, which indicate that the function takes data, right? Takes data when we call it. Oh no, I'm gonna wrap lines, right? And then we have arguments, right? Which is the data that we pass into functions, right? The thing about parameters is that they're actually variables. They are variables that become initialized to the arguments we pass into it. The variable is then available for use within the function body. Okay. At the very end, if you want to take these notes, I'll have them up on the screen and then you can copy them if I'm going too quickly. Okay, so let's demonstrate what this means. This is definition heavy, so let's see it in action. So I'm going to create a new file, touch value.js. Gonna hit enter, and let's open that up. All right, so let's declare a function, or we're going to define a function, and I'm going to use a function declaration. So that's using starting the line with the function keyword. Then we're going to write the function name, and then we have the parentheses. And then within the parentheses, I've defined one parameter. So that means whenever we call this function, we should pass in a piece of data. Then I write the function body with the curly braces, and then usually what we do is we hit enter just to open it up a little bit. So what I want to do is I want any data. So we've defined a parameter, which means that we want to pass in a piece of data whenever we call the function. So what I want to do with this function is that I want to log whatever data that we pass into the function. Okay, so I'm expecting a name. So whatever name gets passed into the function, I want to log that name. That's basically what this code is saying. So then, let's create a variable. Let name, or let's write let my name because I want it to be different from the other one. Let my name is equal to Grace because that's my name, and let's call the greeting function, and we're going to pass in a piece of data, which is I'm going to pass in the variable. I could just as easily do that. I could just straight up pass the string itself, but for this example, I'm going to pass in the variable. So then what's happening here is that I passed in a variable, which is currently the value stored in that variable is the string Grace. So then what happens, again, I mentioned that the name, the parameter of a function is actually a variable. and the variable will become initialized to whatever value we pass it into it. So this is the same thing as saying almost name is equal to, because I passed in Grace, it's like saying name is initialized to Grace. But remember before when we talked about how are values stored within variables? When it's a primitive value, we store the value directly into the variable. When it's an object or an array, we store a pointer to that array or object into the variable. So because this is us storing, we initialized the parameter to be whatever argument we pass into it, and the current argument is a string. That means we're currently storing the string Grace into the variable name. And that means if we log name, we should get the value Grace. So Grace should be output to the terminal. So if we run the file, limit value.js, we can see it's Grace, right? And basically, when we're passing in a primitive value into our functions, we call it pass by value. Okay, so let's break down what just happened. So again, here's our function. We have pretty much the exact same function, except this one I decided to put the hello string before it, so we're just concatenating it together. So I can actually change that here. Plus name, and so when I log it, we now get hello plus the name that we pass into it. Okay, so if we break it down, after the function declaration, we have we've declared the variable myname, which is we're creating the container in JavaScript memory and then labeling it myname. And we assign it, we initialize it to the string Grace, and remember the string is a primitive value, so that means we're storing the string directly into the container. Now we call the function with the value of myname, which is the variable myname, which the current value is Grace. So what we're essentially doing is we're saying we're initializing the parameter to be equal to the variable myname, which is the same value as myname. And as we know now, when JavaScript looks up in memory what value is currently stored in myname, it's the string Grace. So that means name is equal to the string Grace, which means, again, we're creating this container labeled name and somewhere in JavaScript memory. We're storing the value string Grace into it. And remember, because it's a primitive value, we're going to receive a copy, because we can't have this string referenced by both containers, right? We have to store a copy because it's a primitive value. And so when we log the string hello and a space concatenated with the current value of name, JavaScript looks up the container, and we can see that the container currently has the string Grace stored into it, and that's why we get hello Grace output to the terminal. Okay, so this is pass by value. Basically, if we pass a primitive value into a function, it's pass by value. But what happens if we pass in an object or an array? This is pass by reference. So I'm going to create a new file, reference.js. I'm going to open up reference.js, and I'm going to create a very similar function. So function declaration name is going to be mutate. There's a parentheses, and I'm going to indicate one parameter. I'm going to define one parameter, and based on the name, we can infer that I want to pass in an array. So within the function body, what I'm going to do is I'm going to reassign whatever's at index 0 to be another element. In this case, it's going to be a string. So I'm trying to mutate the array that we passed into it. So that numbers is equal to an array with 3 numbers in it, 1, 2, 3. And I'm going to call the mutate function and pass in the numbers variable into it, right? So then, after I call it, what then do we think happens to numbers? Because I've called the function with the numbers array passed into it, and within the function body, we know that the element that's at index number 0 is going to be reassigned to something else, right? It's going to mutate the array that we pass into it. So then afterwards, if I call the mutate function and then call the value of numbers afterwards, we should see that we mutated the array. Right? So this is called pass by reference, right? So let's break it down. We define a function declaration format. We call it mutate. There's the array. Within the function body, we assign index 0 to be something else. So again, we declare the numbers variable, and that means somewhere in JavaScript memory, we create a container that's labeled numbers. We're initializing it to an array, which means the array will be created somewhere else in memory. And what we're storing into the numbers variable, the numbers container, is going to be a pointer. It's going to be a reference to that array. We don't store the array into the container, we store a reference. When we pass in the numbers variable into mutate, what we're essentially saying is, remember, because the parameter will be initialized to whatever value we pass into it. So we're essentially saying r is equal to numbers. By passing in numbers into the function call, into mutate, we are saying r is equal to numbers. We're assigning r to be the same value of numbers. And as we've shown in the previous exercises, when we initialize a variable to be the same value as another variable, but that variable is pointing to an array or an object, that means we're also going to store a reference to the same array or object. So r is now currently pointing to the same array. So what happens when we have two variables that are pointing to the same array? If we make any mutations from one variable, that change is going to be reflected in both variables because in fact they're pointing to the same array or object. So within the function body, what I did was I mutated the array referenced by r by reassigning index 0 to be something else. But because again, numbers is pointing to the same array, the change is going to be reflected in the same in both arrays. Okay, that's all passed by references. So if we pass a function, if we pass an array or an object into a function, it's called pass by reference because we're passing a reference to an array or object. And if we pass in a primitive value, it's simply referred to as pass by value. Okay. Cool. I do have more quizzes for you today, but I unfortunately won't be able to get to them because of I want to leave the floor open for some questions. But yeah, thanks so much for attending. That's basically all I've got for you today. Just a reminder, please fill out the feedback form if you have a chance. And as I mentioned before, if this course is helpful for you at all, if this webinar was helpful for you at all, you can mention it in your assessments or in the course feedbacks or within that Google form link that I've provided in the chat. And yeah, I'll always stick around again for any questions anyone has regarding this material or any other material regarding JavaScript and Launch School. Okay. Okay. I think that's about it. I don't think there are many questions today. So I will be cutting here. Yeah, hope everyone has a great rest of their night.